Hi everybody. So in this video, I'm going to show you how to solve inequalities using graphical methods. So we're given two lines, L1 and L2, and L1 has the equation y equals 2x plus 6, and L2 has the equation y equals 5 minus 3x. For part A, we've been asked to work out the coordinates of the intersection between L1 and L2, which is this point here. Then for part B, we've been asked to use this to write down the solution to this inequality. So the first thing we need to do is we need to find the coordinates for a point of intersection. I'll label this as point P. And at P, the two lines are equal to each other. So we can say 2x plus 6 is equal to 5 minus 3x. Then we can solve this equation to work out the x value at this point. So if we add 3x to both sides, then these two will cancel. So we've got 5x plus 6 will equal 5. Then we can take away the 6 from both sides. These two will cancel. So we've got 5x will equal -1. Then we can divide both sides by 5. These will cancel. So we're left with x will equal -1/5. So that's the x value at point P. We can show this on the axis as -1/5. We can work out the y value at this point by substituting in this -1/5 into either of these two equations. I'm going to choose L1. So y will equal 2 lots of -1/5 plus 6. So y comes out as 28/5. So P has coordinates -1/5 and 28/5. Okay? Then for part B, we can use this point to solve this inequality. We know 2x plus 6 is the blue line and 5 minus 3x is the red line. And because the red line is less than the blue line, we can visualize this inequality as the red being below the blue, which is from this point onwards. You can see the red line will always be below the blue line. So this will always be when x is greater than but not equal to -1/5. So for our solution, we can write x is greater than -1/5. Okay, let's look at question 2. In question 2, we're told that L1 has the equation y equals 2x plus 15, and L2 has the equation y equals x squared. Again, we've been asked to work out the coordinates of a point of intersection between L1 and L2. If I label these 2 points point A and point B, and then we've been asked to write down the solution to this inequality using the coordinates of these 2 points. So we know at A and B, the two equations are equal to each other. So 2x plus 15 will be equal to x squared. We can solve this quadratic by moving the 2x and the 15 to the right hand side. So x squared minus 2x minus 15 will equal 0. So we get x minus 5 multiplied by x plus 3. So our x solutions are 5 and -3, which we can show on our graph. So we've got -3 here and +5 at B. And we can use these 2 points to solve this inequality. We know that 2x plus 15 is the blue line and the x squared is the red line. So what we want, because it's going to be greater than, we want the blue to be above the red, which is when x is between A and B. Can you see that this blue line is always above this red line? But as soon as we go beyond 5 on the x-axis, the red goes above the blue, and below -3, again, the red goes above the blue. So our solution then is when x is less than 5, so traveling in this direction, but greater than -3. Okay? Let's try one more question. Okay, so finally, we've been asked to find the set of values of x. for which the curve with equation y equals f of x is above the line with the equation y equals g of x, and we've been given f of x and g of x here. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you're ready to go. So I'm just going to label f of x in red and g of x in blue. And we'll sketch our axes, and then we can sketch f of x. We know g of x will have a positive gradient and a y-intercept of positive 2. So now we have our two sketches, we need to find our points of intersection. We'll be at this point, we'll call A, and at this point we'll call B. And again, at A and B, we know the two lines are equal to each other. So 2x squared minus 3 will be equal to 3x plus 2. Then we can work out these x values by solving this equation. So we'll move the 3x and the positive 2 to the left-hand side. So 2x squared minus 3x minus 5 will equal 0. We can factorize this. We get 2x minus 5 multiplied by x plus 1. So x will equal 5 over 2, and x will equal negative 1. And we can show these solutions on our graph. So we've got negative 1 at A and 5 over 2 at B. So we were asked to work out when f of x is above the line g of x. And you can see that this is when x is greater than 5 over 2 in this direction, and when x is less than negative 1 in this direction. So we'll write x has to be greater than 5 over 2, or when x is less than negative 1. Okay, well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.